I'm touching, although I would like the RPM to be slightly higher. This is as much as I'm going to get out of it right now, so here we go. The casting is rigid enough to endure this kind of operation, even though this is of course quite prone to vibration, which is also a reason why I'm taking such extremely light cuts. So, even though I'm a bit concerned that the mill will refuse to start again, I would like to take a small break to verify that the rear side is still where I had drawn it, and that's okay. So we are free to go ahead. So we are done with the bottom, which is quite an important step, because now we have established one surface that we can use to clamp the workpiece in, which is parallel to the center line. So I'm going to go ahead and drill the section under the cylinder as far as I can get. The rest, like with the other one, it's probably work for a file, but since this is aluminum, it's not a big deal to do it that way. As you see, we now have a nice firm and parallel surface on which we can set the casting down, not like that, more like this. I've meticulously cleaned the vise internally, so there's no dirt, no chips left in there. And I can check the scribe line on both sides, and I see that it is about the same distance above the jaws, which means that I'm parallel with the jaws. That's also what I feel. And if I tap it with a hammer, then you can hear that not much movement there. So clamping this, and then we can go ahead and mill off the top. That's a very light cut. I'm happy with that. Backing off the mill somewhat. So that I'm over the cylinder body, and there I'm bringing it down again until I hear it touching. Now I can still see that the cut on the front side of the cylinder is wider than on the bottom. That's because the line which runs through the center of the of the engine is not 100% parallel with the casting. So the only way to get to work that out is to take off more. So that's the bottom section flat, the top section flat. The next thing I want to do, which also needs to be flattened out, is this section here, which is the where the valve inlet, where the inlet for the valve is going to go, and that I'd like to be flat with the surface of the machine as well. So while we are at it, I'll move the mill, or the workpiece actually, to this side. Note that I picked a pretty wide end mill, a 2-fluter. I like 2-fluters because they are stronger, and that way you can cover a lot of width in one cut. I think this is a 12 diameter end mill. There's plenty of travel left. But here I want to be gentle, so I'm going to start the mill, take it down until it touches, and then see how much I need to take off in order to get this whole section flat. So while changing setup, I noticed that I also had to change the battery on the camera. So here we are. So it turns out I have to use my 20mm 4-flute end mill, because that is the only one who has the height to cover the whole of the front of the casting. Otherwise I would have to do it in 2 passes, and I would not like to do that if I can avoid it. So too far already. Okay, let's see if we can set this up. I need a bit more at the bottom. Oops, that way please. Okay, the mill now covers the whole front of the engine, of the casting, if you like. I'm going to start it and turn the table in the Y direction until it touches. Which is here. Now I don't need to take off a lot, so let's begin with I'd say a quarter. So, all in all, this pretty much completes this this part of the video. The next one is probably going to be about drilling holes. I think I'll clean up the casting to get away of these ridges, but I'll do it by hand using a file. And yeah, at least what we have accomplished now is that our casting is lined up with the centers and the center lines that you have on the drawing. Note that I didn't use any measurements because none of these outer dimensions is that critical. Main thing is that we have square and parallel surfaces. So, thanks for watching. I'll see you in the next part.